The second half of our lecture, we're going to talk about pedigrees. So pedigrees are a family tree that follows the genetic relationship of a trait through the family. So it shows specific trait over several generations, and it talks about carriers, which are heterozygous individuals that don't have the trait but can pass it on to their offspring. This is an example of a pedigree. It lists males, females, parents, grandparents, grandchildren, offspring. It lists each generation with a Roman numeral, so 1, 2, 3, the fourth generation down here. It talks about who's married to whose kids are whose, all of those things. And so we're going to make our own pedigree today. Okay, so symbols you need to know. There are a lot of them, but really important ones. Males are squares, females are round. If there's a line between them, we know that they are married or mated. If there's a line leaving those two to make new offspring or new circles and squares, those are their children, and in the order of their birth, the first one born on the left, the last one born on the right. Twins are connected by a triangle, like an angular line from the same birth. That's non-identical. If they're identical twins, there's also a line between them. It talks about heterozygous, homozygous, ones that have died have a line through them. Yeah, okay. So we're going to talk about, I'll go through all of these. But here's another example. It's just going to look like a lot of boxes and circles linked together with different shadings in order to specify their genotype. This is an example of a colorblind or a pedigree for like who's colorblind in the family. So in this example, there's a male that is colorblind mated with a female that is not colorblind or a carrier, and or actually, yep, not a carrier. Yes, she is a carrier. Not a carrier, but the dad passed on his colorblind trait to her, and then the mother passed on a normal, healthy allele. And then we look at this and we see a carrier and a male, and the carrier has passed on her genes to the male, and so her son is colorblind. Okay, so a human pedigree is a diagram that traces the inheritance of a particular trait through several generations. Alright? So a carrier is a person who's heterozygous for a genetic disorder. They don't actually show the symptoms of the disorder, but they could pass it on to their offspring. And carriers are really important in your pedigree because they help you determine the genotype of the offspring and the parents. So a pedigree, like we've said, is a symbolic representation of a family and the alleles they have. So this is a male, this is a female, this would be an unknown gender. Useful if the child has died at birth, or if the gender of the child is unknown. Okay, this means they're married. This means they were divorced. This means that they were married and then divorced and then remarried. This means the person has died or is no longer living. Alright, so what a collection of symbols could show is a couple who is married and they have a son and a daughter, and the daughter is older because she's on the left. Alright, what could this one show? Well, I see a male and a female. They've married, they have an older daughter, a younger son. The younger son then also got married and they've had a son. Alright, so this means that the person is homozygous for the allele. This means the person's heterozygous for the allele. And this means the person does not have the allele. For dominance and recessive, it doesn't matter which is colored darkly. You just have to talk about which allele you're showing. You're going to make a key for your pedigree that says maybe the dark symbol means you don't have the colorblind allele. Maybe the dark all the way filled in means you have both the alleles, both the alleles for colorblindness. You have to specify what you're talking about. Okay, so the brown allele is what we're looking at here. And so it is black, and the blue allele is white, and brown is dominant. So I have a brown-eyed parent mating with a brown-eyed mother. They make a heterozygous daughter, a homozygous brown son, and he marries a homozygous blue allele wife, and they have a heterozygous son. So who has brown eyes? Anybody that has any of the black alleles, or any of the black shaded in. Everyone except for this person. Okay, so this is you. We're going to imagine this triangle. We don't know your gender, I mean, or your sex, like you do, but we could have about anybody. So this is you. Who is this? It's your sister. How about this one? Well, let's trace it back. So that's you. That's your mom and your dad. That's your mom's line going up. Oh, that's your mom's dad. So it's your maternal grandfather. Alright, who's this? Well, let's go back. Here's you. Here's your dad. Okay, your dad had a kid with somebody who's not married to him anymore. He had a daughter with somebody who's not married to anymore. So it must be your half-sister. Alright, what do we know about your grandmother up here? Well, we know she's not living anymore. Okay, who's that? Let's see. Let's trace it back. So you have a mother. Your mother has a brother. Your brother has a wife. So it's your aunt. Okay, let's talk about the big nose allele. It's recessive. So the big nose allele is going to be black. So who has a big nose? Well, you do. And then also, way up here, your aunt. What's the genotype of your cousin? This one right here. He's heterozygous. And we know that because we have a homozygous recessive, homozygous recessive makes me the homozygous dominant. That means we're going to make a heterozygous individual. So here is a larger pedigree of princes and princesses and all of the people that have hemophilia. And so part of the reason we see hemophilia in this is because of people that are related, possibly getting married, or we also just see that, so we see a lot of men with this, right? Rupert, Valdemar, Henry, Fred, Leopold, Gonzalo, all of those people are men that they are hemophilic males because they have only one trait or only one X gene that isn't covered up. And so if they only have that one X gene that's defective, that's what they get, and that's going to be their, that's what they're going to express. Alright, so let's try making a pedigree. So in your notes, sketch a small pedigree depicting a married man and woman with 3 children, 2 girls and a boy. The boy is the middle-aged child, and he is colorblind, and the mom is a carrier. So pause your video, go ahead and do that, and then when you're ready, come back to look at this. Alright, so we're using the black here to represent the carrier mother and the colorblind son, and then 2 females that it appears are not carriers at all. And the son is the middle child. Alright, so what your assignment is to go to the back page of your packet, and there is a Flintstones pedigree there. And your job is to make your pedigree of the Flintstones. You're going to have to make a key for this, and you're going to have to specify which alleles you are representing for each individual, or for all of the individuals, and you'll do that through a color key. Please mail me if you have any questions. That's all I got.